Good morning or good evening to all, and welcome to the Data-Driven Community virtual meeting. A few words about the Data-Driven Community in general. As you can notice at our website, we are managing two branches of activities. If you scroll down the page a bit, you can see the upcoming events. On the right side of the page, you can check the upcoming weekly meetings of the Cloud Data-Driven User Group, like today. On the left side, the second branch of activity we run is an annual conference called Future Data-Driven Summit. The Future Data-Driven Summit is an annual conference, joint conference of several user groups in the data and AI platforms. We want to remind you, everyone, don't delay getting your early registration completed. And today you will see why in 1 minute. The early registration can get you to specialist updates. Information will be sent by email. And what we are going to do now is a nice raffle. Become a sponsor. First of all, I want to remind everyone, if you're familiar with someone that can help us sponsor the conference, please contact him. Ask him to contact me. You have all the information in the website, and I will put in the chat as well after we will start today's lecture. Just remember, the sponsor that we need is for you. All the conference is organized voluntarily. The speakers are volunteers. The team are all volunteers from the community. So why we need the sponsors? Because we want swags for you. And today we will go over a raffle for early registration. So if you are fast, go and register right now, because I'm going to select random person that will get today a gift. And from now to the day of the event, we will run several raffles like this. So again, if you are fast enough, go to the page and register now. Don't forget, when you register, you will get an email to confirm that the email that you register is actually active email. We raffle only between the people that confirmed their email. So you need to register using the form like you see in my screen, and then you will get email. You need to click it, and immediately your status will be changed to active. And what I'm going to do now is the raffle. So this is what we prepared. So as I said, become a sponsor or connect me to someone, if you are familiar, that can help us. When do we run the raffle? From time to time, during the weekly meeting of the Cloud Data-Driven User Group. What can you get? During the event, we have more swags, physical swags as well, like hard copies of books. But for the early registration and for the before the meeting, we can only raffle virtual swags, and we will give away ebooks, gift card, and license that we have. We are going to do the raffle right now, and I want to do it live. I want to show you exactly what we are going to do, and we will do it. So I will show you the query as well. This is our database. It is secure, of course. We use all the security of SQL Server, dynamic data masking, row-level security, obviously users and database level security. And what we are going to do is, first of all, in the raffle, I will remove all the tests, because we have done a lot of registration for tests. Not a lot, but there are about 10 tests that we need to remove, and we will only verify raffle between verified email, those that the status are active. As I explained before, after you register, you will get an email, you click it, and then the status will be changed. All the registration, by the way, is done using our application. So until now, it is working great. If you find any issue, just contact me because I develop it and I can fix if there is any issue. What we are going to do is to select top 50, but the raffle is only for one each time. Why I select top 50? Because we will go through the first one, we will contact him. If he will not respond, I will contact the next one and the next one until the first one that will respond. Probably it will be the first one because we work only with active people that confirm their email. But to make it more clear and public information, I will select the first 50. We have hundreds of registration, of course, and I will save for myself this list so I will be able to contact the next one. This is not a raffle now. I'm just going to run the query to show you the idea that is changed. We do limit for last registration for each email. There are a few people, not a lot, but there are a few people that register more than once. Probably it didn't work for them, that's okay. We filter it, we take only the last registration, and then I'm sort everything randomly, and I get the top. Okay, so this was for the people that understand about query, and now let's run it. This is not a raffle, I just want to show you the idea of how it will go. And the information that we get is every time 50 different people. So every time that I execute it, I will get a different people. The first one will be the one that get the gift of today. So let's start. This is the real raffle. Again, I will give you 20 more seconds. If you still register in the last minute, okay, obviously you can register after the event as well. Okay, let's give it like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is the real raffle. And this is our winner. I will copy all the list, so I will be able to work on this afterward. Awesome. And we can continue with today's meeting. And again, I will put all the links in the chat, so you will be able to register if you haven't yet. During the event today, during this meeting, please feel free to use the chat for questions and for discussions as well. This is a user group meeting. It's not a conference that we need to be strict with the time and go from one speaker to the next. So feel free to use the chat. You are also welcome to use reactions. I loved it a lot. It doesn't interfere with the course of the meeting. If you hear something that you love, like, or you want to clap hand virtually, of course, then feel free to do so. You are more than welcome to contact any of the community board if you have any suggestion or question regarding the next meetings. I will go through the board very fast. Jen Joseph is the founder of the community and the co-admin. Anna Weekly is the second co-admin. My name is Ronen Arieli. I'm from Israel. I work as a senior consultant in the field of data platforms and architecture of enterprise level system. And I'm the third co-admin of the data-driven community. I will be hosting the session today. So those are the board members. And today I'm very happy to have with us John Martin. John is a very known person in the community, speaking many user group and event. So John, you can share your screen and add a few words about yourself.
Yeah, of course. Give me 1 second, I'll get my screen shared.
Wait,
and you can see the title screen.
Okay, and during the meeting, I will follow the chat all the time.
So I've got a multi-screen set up here. So I've got the slides on one, and I've got the chat window and everything here right in front of me as well. So feel free for anyone who's got questions. If you're not, if you just pop them in the chat, I'll answer them in due course as we go through. So that's fantastic. Thank you very much. And just to confirm. Oops, sorry, go ahead. All good. I take it we
just before you start, since you gave me a few seconds, I just want to give you something very funny. My setting was on Hebrew, so I actually get in the transcript everything that you said in Hebrew and everything that I said.
Awesome. It's the only time that I speak bad English and
Teams
English.
Translate it. So.
I was getting back to speak. So that's thank you very much. I really appreciate it. So thank you very much, everyone, for your time today. I really appreciate you joining the call. I'll go through who I am in a moment, but the session I'll be presenting today is entitled Data Engineering and the Rise of the API, and it's really sort of built on my experience over the last, I say, few years, decade or so of data engineering and development and work with data platforms and the way that data sources have changed in that time. So we'll look at those. We'll go through them. Like I say, feel free to pop questions to the chat window and I'll answer them as we go through. So who am I? My name is John Martin. I've been working in the technology industry for nigh on 20 years now, specifically 15 of which has been spent in and around the data platform, predominantly the Microsoft stack. Spent some time working for Microsoft and for AWS, using the technology stacks there, including the analytics piece, ETL, what have you, so Data Factory. I've worked with SQL Server for more years than I care to remember. My contact details are there. Please feel free to connect with me on LinkedIn. My email address is there if you want to send me an email. If you think of anything after the case here, let me know. I'll also publish the slide decks and everything up to my GitHub repository, and I'll post a little thing on LinkedIn to say where they are with the links and what have you as well. So that's not a problem. I'll pop this slide back up again at the end, so you've got my contact details there. So, what are we going to be discussing? Really, we're going to be looking at how we used to get data. We'll run through the history, data engineering, that side of things. Back when I started, it was sort of BI or ETL engineering, that type of thing. But now sort of data engineering is, because it's quite a broad spectrum that we deal with. And we'll sort of talk about how APIs were used 15, 20 years ago, back at the sort of turn of the century, which is quite scary to say now, through to where we are now, what the differences are and how we need to sort of look at and interact with these new data sources, and then sort of some of my wish lists and things we should probably look out for in the future if we are developers developing APIs as well, some of the things we want to start considering. And also if you're involved in a project where a business is changing its strategy and bringing platforms in, some of the things you might want to consider about and injecting yourself into their decision-making process. Okay, so we're going to go through those things today. There's going to be a bunch of slides. We'll look at some demos, and then we'll go from there. So start thinking back when I started my career, back in the sort of early 2000s, the ecosystem for hosting applications by the companies that we worked for, or the companies we worked with, it was predominantly on premises. We owned the equipment, we bought the licenses, we installed the software, we ran the software, and it was all something that we had a lot of control over. So it really was a case of, most of the time back then, we would be going direct to the database engine itself, whether it's Oracle, whether it's SQL Server, whether it was MySQL, any number of those database engines, we would be interacting directly with it. The tabular data form, we'd be using SQL We'd be writing the queries. We'd be saying, okay, well, I want to retrieve these columns from these tables. I want to join it to this. I want to filter it with the where clause and what have you. And we had all that control. We could go in, we could do that. If we wanted more performance, we could throw more hardware at it, or we could tune the queries, or we had a lot of control. Then it comes to the sort of security aspects of it. Again, it was within our boundary a lot of the time. And when I say within our boundary, I mean the corporate network, which would be typically very isolated. Obviously, there was some internet connectivity, but a lot of those applications were never presented to the internet or internet facing for internal applications. A lot of the time, you had to be either in the building, or in a rare case that you were a sort of remote user, you'd be on the end of a VPN to be able to connect to them. And that meant that we had a lot of control over the credentials we were using. We either use SQL authentication or Windows-based authentication, potentially LDAP, things like that. One or two other options available to us. And we'd be pretty certain that, okay, well, we're in a secure network environment. So again, those considerations that we're working with there about, okay, well, can people sniff on data? Can they do sort of person-in-the-middle attacks? All of that sort of stuff. The whole ecosystem was slightly different. The world was a little bit different, and like I say, we had a huge amount of control. And if it wasn't direct database access, we were typically dealing with files, and those files would be coming in through potentially scheduled exports from applications, through batch jobs and things like that. I've worked in a number of places where Dave from accounts would generate a file and drop it into a file share somewhere or email it to someone. And then it would go through sort of a couple of pairs of hands and it would drop down into somewhere to be picked up. A lot of FTP and SFTP was used as a data source. Well, the files would come in, but again, it was still files. When I use the term CSV, I use that sort of pretty sort of generically to mean any sort of structured text-based file. But obviously you can end up with different nuance there. You'd end up with things like the pipe separated, pipe delimited, or whatever, various different options. But fundamentally, structured files that we could ingest, and they would be coming in on a regular cadence, but sometimes they may be a little bit late. But they weren't huge, and that's the thing. The data volumes back then typically were not large compared to what we see today from a data volume perspective as well. When you think about big data, it's really about what you can and can't process efficiently. So even back then, we would may consider sort of tens of gigabytes sort of large data at that point when we're dealing with some very sort of what we would consider now archaic technologies around storage, SAN storage, local storage, data transfer rates on the networks and things like that. But today, those volumes of data we can easily handle on laptops, for example. But back then, we would have a solid ecosystem. We'd have dedicated servers for a lot of it, and that's how we would get our data. And then that was from an analytics perspective. I'd be ingesting that data, I'd be pulling it into a data warehouse. Then I'd be using reporting services or crystal reports or another mechanism for reporting that data. And then we start thinking about, okay, well, back then, how were APIs used? And did they fit into the mix here? Well, kind of. When we start thinking about how our API ecosystem came together for applications, the best way to think of it is the name gives it away, the application programming interface. Back then, it was predominantly for integration of applications in a sort of transactional messaging platform sort of manner. Very often there'd be something like, say, an enterprise service bus in the mix where you'd have one application passing to the bus would then do some routing and it would go to where it needs to be, potentially to a couple of different services. BizTalk being a good example of something along those lines as a messaging platform I've worked with in the past. And again, pulling things together where I had multiple sources, but again, it was very transactional in nature, the sort of messaging profile. And the APIs were really geared towards that. You have obviously SOAP, RESTful APIs as well as sort of bespoke mechanisms as well. Thinking about potentially some of the file-based interfaces, if you will, of VDI, you have very prescriptive formats there that would be used for data interchange between businesses, and they could be regional, could be industry vertical specific as well, down to sort of purchase orders, sales orders, potentially sort of some of the manufacturing details would differ between, say, Europe and the US for the EDI and the interchange formats there as well. So it was a sort of much more focused on application facilitation, really, rather than, okay, well, I need to get a large amount of data out of this application. I want to use it for some form of analytics purpose. Okay, so we start thinking about, okay, well, how has that changed? And then we start thinking about, okay, well, what are we looking for in sort of APIs today when it comes to data engineering? And one of the key sort of strategic changes that I've witnessed through the last decade has been the real heavy adoption of SaaS-based products for businesses, moving their line of business applications from being hosted internally to the cloud, leveraging external organizations to do work for them, but still have a lot of that presented. So good examples being CRM platforms. Back in, when was this? It would have been 2010-ish, doing a sort of Dynamics AX implementation with Dynamics CRM as well. All of those be going on premises. Move forward to today, and the Dynamics platform is largely cloud hosted. That's the sort of first choice for a lot of people to consume those sorts of platforms. I think Salesforce as well. Predominantly, there is. It's on the end of the sort of internet for us. We can go to, we talk to it. It's through the browser, but we don't have that installed on premises. We don't have access to those databases, so we don't have a lot of that control that we used to have. We're now going to be interacting with systems that are remote. They're hosted externally. We don't have the control. We're at the very much at the sort of mercy of those providers for how they're going to be granting access and everything that goes along with that. So you start thinking about, okay, well, do I have what's my security sort of setup look like for that? Well, you're dealing with things like OAuth potentially. You're dealing with basic authentication. You're dealing with unauthenticated, certificate-based. Any number of different ways of being able to interact with them, but the traditional sort of either Windows authentication or sort of direct database application authentication mechanisms, they're not there anymore. So we've got to think about how that works, and there's some constraints around that, which we'll discuss a little bit as well. So again, you think about, okay, well, now it's externally hosted. What are we looking at for dealing with that? Well, that means it's going to be potentially higher latencies. That's again something to start thinking about. Is, well, what's the impact of that when I start pulling in large volumes of data? So from an application perspective, it's pretty benign. They're responsive. There's multiple calls, but again, it's very much geared towards how do I get my applications to talk to another. We start thinking from a data engineering perspective. I want to take these line of business applications and I want to generate a sort of analytics solution off the top of that. Again, a lot of those analytics solutions now are sort of cloud-based in things like Databricks, Fabric, Snowflake, Redshift, EMR, any number of externally hosted sort of or cloud-hosted scenarios where we've got varying degrees of access again. So you start thinking about, okay, well, I need to get the connectivity working here. How do I do that in a secure way? How do I guarantee access? When you start thinking about, okay, well, I'm going to need to leave a secure network boundary potentially to go and connect to these systems. Okay, well, how do I do that to be able to ingest data effectively? What are the new threats that maybe sort of surface around that for data exfiltration? If I get something like, say, a supply chain attack into my ETL pipelines or my data pipeline sort of development environments, because obviously if you're reaching out with something, you can push data just as much as you're pulling it, because when you start thinking about interacting with REST APIs, we're using sort of standard sort of HTTP verbs, so get, post, put. How do we handle the potential exfiltration of data in that mechanism, whereas historically that might not necessarily have been such a consideration for some of our ETL platforms. So again, we've got a lot more to think about when it starts coming into this complex environment. Then we start thinking about, okay, well, what is the API going to look like on that back side of things? What are we going to be talking to? And this is where you've got SOAP APIs, REST APIs, GraphQL APIs, more often than not. Now, SOAP I don't see very often, or at least not something that I'm going to be looking at using. There is also OData, which I'm not mentioning here. Again, it's not something I see a lot of when I'm dealing with some of the sort of third-party host applications. But obviously, depending on what you're dealing with, it's going to be highly variable. And that's one of the things that is very much apparent when you're starting to look at transitioning your analytics solutions away from your traditional sort of on-premises scenarios where you've got it's Oracle, MySQL, PostgreSQL, whatever. There's a finite number there. The way that someone implements their API is going to be potentially unique per application. So again, that variance and the variability that we'll see in that environment is going to be increasing complexity potentially over a period of time as well. So we've got SOAP APIs, which primarily deal with things like XML. We've got REST as well. So we've RESTful APIs, which is what I would refer to as the de facto mechanism for interacting with most applications. When we start dealing with things like Salesforce, Xero, GitHub, you name it, those applications are hosted externally. REST is the predominant way of doing it. There's more and more sort of bringing graph QL APIs online, which help to alleviate some of the challenges of using REST APIs when we start looking at how we interact with them effectively. The big difference there is, I mean, REST APIs are really sort of designed for, okay, just I'm going to call you, you can give me that information, you can cache some of it, but I'm going in, I'm saying, give me everything off of the user's endpoint or the repository endpoint or the opportunities endpoint. And depending on how those endpoints are implemented, depends on the level of filtering that you will be able to apply to them in one form or another. In certain cases, you cannot sort of turn around and say, well, I want to apply a sort of where clause to this particular set of data that's coming back. So there is no way of filtering it. But there may be on another one. So it could be a case of in that. Think about users, for example. A common one will be a case of I want to ingest all of the users who've had updates on their user account since my last data ingestion. Some APIs just will not facilitate that. You just got to go and pull all the user accounts down at the same time. But if you interact with a specific user via an account on the API, you can provide actually where the last updated is greater than or whatever, or if it's greater. And so there's various different options that are available, and it's going to come down to how they're implemented. A lot of the time, it's going to involve going and reading the documentation. That's one thing that you get very, very used to very quickly, is reading varying quality, varying levels of quality documentation around the APIs, what they support, how they support it, some of the nuance around it as well. The Graph API, the GraphQL API element is about giving us more power to be able to say, I wanted to use a more sort of query-driven approach to being able to retrieve the data out of these APIs. So again, we can deal with that sort of overfetching or underfetching model where we're dealing with REST. We can go in with GraphQL and we can be a lot more specific about what we want to pull down. What that means from a data engineering perspective, in my experience, is okay, well, sometimes I'm going in and pulling all of the fields down for the user accounts or the opportunities or the sales orders or whatever it is I'm pulling in, and I'll put them into my landing area, and then I will restrict that down as I pull them into different parts of my lake or lake house, depending on what the requirements are for servicing the questions that we'll be asking of that data. Versus, well, I'm only going to get exactly what I need, but that means if I want to change that question, expand it, contract it, whatever like that, I've got to go and go back to source and modify my source queries. So again, we start thinking about that balancing act of which is going to be the best way to ingest the data from that data source at that point in time. So, and then we start thinking about the data formats that we're interacting with. Historically, like I say, it's been very tabular in nature, but now a lot of them are very much sort of schema on read, sort of semi-structured data with XML or JSON predominantly. JSON, again, is almost a de facto standard when you're getting things back from REST APIs. And that can have a big impact on the way that we pull that data in, the sort of volume of data that we're landing into cloud storage or what have you for our landing, and then moving it through sort of the medallion architecture. But one thing to be very aware of here as well is that obviously that's going to potentially flex by record, depending on that sort of structure that you're dealing with. You think about some of the older tools that we were using, integration services, which was very inflexible in its nature when it came to converting things from JSON into sort of more structured or the semi-structured into structured formats. Now we've got a lot of options about how we're breaking down the way we do our data pipelines, which means we've got a little bit more versatility in that regards. And the JSON side of things is It's pretty human readable as well, which is nice. But again, when we start thinking about how we're going to land that data, the structure of those JSON files, the number of them, the size of them, things like that are going to have a bearing on how our systems then ingest them further down the line. So we do the ingestion from the API and we land it. And if we just land one massive document, then that's going to potentially limit some of our parallelization for being able to ingest that data into an engine. Then if we land multiple files, okay, we've got that, but do we end up too many small files? And you'll look at those balancing points. And then again, especially in this case of things like JSON for dealing with Spark, are you getting one JSON document, which you can't easily parallelize your query into, or are you getting one JSON document per line, which allows it to parallelize it more efficiently and do that data ingestion? If you get the former, then do we need to look at potentially ingesting that data and pre-processing, post-processing it? So there's a lot to think about there. Sorry.
Just to clarify, we see the same slide.
It should say data engineering and APIs with 3 bullet points, line of business apps. Yep, that's fine. So the JSON piece, yeah, that's cool.
Okay, one more, since I already cut you, I remind everyone, use the chat, please. And I added all the relevant link regarding the future data-driven in the community. But use the chat if you have question or discussion. Thanks.
No problem, thank you. So now we start thinking about some of the gotchas when we're dealing with APIs. So we figured out what we're going to be doing and how we're going to be interacting with them. And the first one really is around the authentication authorization. This will vary a lot per API. And even within an application, you'll have varying degrees of it. So we start thinking about GitHub, which we'll look at during the demos. It's got certain capabilities that you can interact with without authenticating and authorizing, and others that you can only get to when you have basically got a context that you're interacting with it in. And again, whether they're implementing OAuth 2, basic, nothing, credentials, personal access tokens, however they're looking at doing that, it's going to be very variable. So again, you've got to go back, read the documentation. Now start thinking just about a very basic OAuth process. So before we can interact and get that data, we need to obtain a token. So we start thinking from a client credentials perspective, I do a token request, I get a token response. Now there is sort of change codes where I can do the initial authorization, get the code, get a specific code back that I then have to put into a website. Or I have to go and do a manual authorization through a web browser window, which I then do a submit to get a token and retrieve the token. There's sort of device flows. There's various different ways of doing this, and what that means is that there's varying degrees of interaction that you'll have to do in order to obtain a token to be able to do the access. And that's not too bad when you start thinking about mobile applications, web-based applications where you've got a user in the loop and things like that, but you want what I refer to essentially as a headless application for something like a data pipeline. Then the token request process, how do we do that in an automated way? Does the API support that initial token generation and retrieval without having a human in the loop or something similar to that, or can it be programmatically handled? Because as soon as we get the token, then we can do the API request to retrieve the data. Okay, so there's a question come in, when using API, do we get JSON response in file format or JSON record format? If it's a file, do we get multiple files? Spark to read in parallel. I'll come back to that question when we get into the demos because it will be a little bit more illustrative of the type of data we're going to be getting back, and then show you how we land that and what have you. So thank you for the question. I'll deal with that one in a few slides' time. So coming back to this one, we've done our token request, we've retrieved it. So that's great. But then we have another little hurdle, which is the token lifecycle. And this, again, is going to vary by implementation. But essentially, you can vary from, well, I'm going to create a personal access token in this, and I'm not going to set an expiry. It's a valid approach. Is it the right approach? That comes down to you understanding the risk profile. Because you could then say, well, actually, I want to expire the token every 7 days, but that means you then need to renew it every 7 days and get that process back in. When doing that, that can be a very sort of manual approach. which is not great, and there's a lot of process that you need to build around that if you want to try and automate it. Then you start thinking about OAuth token lifecycle. Some tokens, again, won't have an expiry. Some will. Some could be as low as, some platforms I've worked with, it's as low as 20 minutes, which when you're interacting in a transactional manner with an API, it's not terrible. But when you start doing analytics type activities of pulling out large volumes of data, making some larger calls, that's something that potentially is going to trip you up. And then you have to start looking at building that into the data pipeline of, okay, well, for every API call, do I want to go back and say, I will go and I will refresh the token? So we start thinking about how that looks. We do our token request. At that point, clock is ticking. So we go and do our API request. We get our data back. And at this point, it's like, do I risk it and go again? And then have the response and then do my token refresh? Or do I do my token refresh, get my fresh token, and then cycle back into the request process? So for every call I'm making to the API endpoint, so if I go the opportunities endpoint, and then I want to go to the sales endpoint, and then the contacts endpoint, for each of those, do I want to do a refresh before every single one? Probably. And again, there's a couple of different ways that process works. So you could just be a case of I supply the token I've got to go and retrieve another one, or one that's automatically issuing a new token every time, or you'll get something called a refresh token, which you then need to submit to obtain a token to allow you to make a call to the API. So we start thinking about how much more complex that can be and how we have to manage that element in our data pipelines, and that can become quite a big headache. And this is where I come back to what I said earlier about if you're a data engineer and you are working for a business or a customer or whatever that is basically looking at their line of business strategy for their applications, and they're going, right, we're going to go to SaaS. You want to make sure that as part of the decision criteria, it's not simply a binary choice of, do you have an API that we interact with? Yes or no. It's a case of, that's the question one. Yes. Okay. If that is yes, how do we access it? What is the information? How is the sort of token lifecycle? What's the authentication authorization process? Does it support analytics type activities effectively? These are questions that really sort of need to come into that process as part of the decision-making process, because you can go and buy a sort of sign up for a 12-month contract with something like, say, Workday or whatever. You invest a lot of money there, and you discover then it's going to take us 3 months to actually integrate it effectively into our analytics solution, versus another option that maybe takes a month. It's because they've got a much more amenable API to interact with, to work with, and be able to retrieve that data. So again, when you start sort of getting involved with this, make sure you sort of try and make sure that comes into the decision-making process, because it can make your lives a lot easier by having a say in the overall process. So the other thing to watch for as well, and this kind of goes hand in hand with a bullet point I haven't got on here, but response body pagination. Now, not really something we used to do when we're doing direct database queries. It's like select from this, where that, boom, give me data. And I get a big lump of data back on the TTS stream or whatever, and then I can pump that through my integration services or ADF or whatever, and I can land a file in a structure I want, or I can put it into a database table or whatever. When it comes to the API side of things, a lot of the time it is, like I say, it's very much application focused. You start thinking about, you go to Amazon or whatever, and you say, show me my orders. And it will show you a page of N number of orders, and you say, right, next page, next page, next page, last page, first page. Fundamentally, behind the scenes, the APIs are doing that when you're making these calls to get your data. So what you're dealing with is, okay, I'm going to have a maximum potentially of, say, 100 records come back on a particular API call. So if I do that, if I've got 1,000 records, okay, I need 10 pages worth of data, which means I've got to do 10 calls, incrementing the page count to go and get that. Okay, so what that means is I'm then making 10 calls to get one block of 1,000 pieces of data. Not great. Where this also comes into it is that a lot of APIs will implement what's known as rate limits. So this essentially is the number of calls you can make within a given time period that they specify. And they do that for a lot of reasons. I mean, things like preventing sort of someone coming in and absolutely hammering the living daylights out of it, pulling lots of data out, denial of service, all that sort of stuff. There are ways and means that they can implement this to protect their environment, protect their system. I completely understand that. But it's something that we have to be cognizant of. And again, it's something that when we start building our data pipelines, we have to be aware of, and we have to start thinking, okay, well, how am I going to handle pagination logic? Because again, whilst there is a standard way of doing pagination, not everybody adheres to it. We'll look at the GitHub API shortly in some of the demos. That implements the sort of RFC standard pagination mechanism around sort of URLs, but other APIs that I've worked with have returned a lump of XML that has a set of integer values, and they relate to the keys or the composite key for that particular thing that I'm pulling back. And because of the nature of the data, I could infer that, okay, well, if I just increment them by 1,000, I'll get 1,000 records back. The reality is, because the way that the system was run, the ITs were not contiguous. So if I did that, I could end up with 1,000, 1,000, 5, 100, 1,000, things like that. So you end up with the variable rates of data coming back, or very variable volumes of records coming back. Whereas if you just use the pagination mechanism they've got, yes, there's more work, but you can be consistent in the amount of data you're going to pull back with every call. And then you've obviously got to calculate, when am I at the end of the pagination? When do I know I've got all of that data? And that's the sort of logic that you need to build into those pipelines. So you've got to think about, okay, we've got pagination. Rate limits are going to be applicable irrespective of whether or not I've got paginated data, because it's going to be related to the number of calls I'm making. The more data I'm pulling and the smaller the pages, the more calls I'm going to have to make. So it is going to become a consideration there as well. You can, in many cases, parallelize the calls to an API, which is great. But again, there's certain limitations that may be implemented by those API vendors or those application vendors with the API to say, right, you can run up to a maximum of 5. Beyond that, we'll start terminating your connections. So again, think about how you're going to access those. So there's a lot we need to think about. And with that, we will have a quick look at some demos. So give me 1 second to bring this over. So I'm going to use Postman. Okay, now this is an API sort of testing tool. There are others on the market. Be aware with Postman that even though I've got a desktop application, it will store all of my information in the cloud as a backup for it. If you want something that's purely local, use something like, say, Insomnia. But fundamentally, I'm going to use this because it's a tool I'm familiar with, and it's for illustrative learning purposes only. So just be careful with the data you're going to put in here. But if I look here, what I've set up is I have a set of variables. I've got globals, I've got auth and my personal access token, which is the one we're going to be looking at today. But if I look at the globals, this is just going to run you through a couple of things. When we start dealing with APIs, we've got our API base path. In this case, it is this one here. So this is the part of the URL that we are always going to talk to. So beyond that, it'll be GitHub, api.github.com /, and then we start getting into the API endpoints and the various hierarchies that we have to deal with there. So we start thinking about how we interact with our data pipelines. We want to make them metadata driven. So this will be something that we look to inject as part of the configuration. And then the extra piece is when we start defining our data sources and how we go about that. That's when the rest of the API comes in. We also have the API version. Now, this is something that is it's something I really like about interacting with APIs. It means that I can interact with this one and they can increment the API version. But because I'm telling them I'm talking to this one, I'm sort of loosely coupled rather than a sort of close coupling. When you think about when we make a schema change to a database, I've got to go at that point in time and re-engineer my queries potentially to say, okay, I need to, what's the blast radius of this change? What do I need to change at the same time? You think about that rate of change. If the vendor increments their API value, a version value, you can say, okay, well, now I can plan for that and I can upgrade things in my own time at a pace that I'm comfortable with. Just bear in mind that it doesn't always have backward compatibility. There are versions that get deprecated or discontinued. Just make sure you're reading up on the documentation, you've got the appropriate notifications, and so that when these changes happen, you're aware of them, and you can plan that into your development life cycles. In the case of the GitHub API, we've got the version number there in this case it's a date. We'll have a look at something in a bit where it's actually a number. But as part of this, we send the information in what's referred to as the request headers, and we'll have a look at those in a little bit more detail shortly. But I've got a key value pair in the header, so I've got the key and the name of it and then the value. Now, specifically, the API key name for GitHub is X GitHub API version. So I need to provide that as a header with this value here as the value. So when that goes out in the headers, that's when I'm in a strong position to say, okay, this is what I'm interacting with. This is the version of your API. Parameterize those because that's GitHub specific in this case. And then finally, coming back to one of the questions earlier about the file format, the data format that's coming back, there's something in the header called the accept header. And this is where you specify what is the supported version or type of data you're going to get back. In this case, we're looking at this application JSON that we're going to be pulling back from the GitHub API. That's what they support. Okay, certain other APIs, you can say XML. There are various different options. We'll have a quick look at those in a minute. But that's what we're looking for. And that's how we'll define what the format of the data we get back in its rawest form in the response body. Okay. I've also got my personal access token, which I've loaded in here. And that's all set up here as a parameter, so I can variable, sorry, so I can not have to specify it anywhere else I need to. So if we look at the ones over here, give me a second. I'll look at the unauthenticated process. So when we come to the request we're about to send, as I said, we've got our API base path, and then this rate limit piece here is the bit of the URL that says, what are we going to interact with? That would be akin to our table in a database query. So I want to go and deal with the rate limit information, passing in the version of the API that we're using, and telling it we're using, we're going to accept the GitHub header information. If I show you the hidden headers, these are ones that get put in. These are the encoding formats that we can handle with user agents, various other useful little bits of information that just go into making up an HTTP header, but not the ones that we're really interested in for the purposes of this. So if I send the GET request, what this is going to do, we're going to send it to the rate limit endpoint. I pull that up. If we zoom in, you'll see here the different API elements that have for the GitHub environment. So the core API, I'm unauthenticated or unauthorized, which means I have a limit of 60 actions within the time frame. I think it's a minute. I have to double check. But I'll go. That's where you're going to read the documentation. GraphQL endpoint, I can't do any calls to it. Search endpoint, I've got 10 and 10 remaining. But you see a lot of this comes back in that regards. And if we look at the console, where's that gone? Just view Postman console. Here we go. You'll see, zoom in. So these are our request headers. This is what goes into it. So that's what we sent. Okay, telling it I'm going to talk to api.github.com. This is what I want back. There's my Postman token. These are the response headers. So this is the headers for the request that we get back. We can see here we've got media types. So that's all good. So dealing with this, here we go. Format JSON, there we go. Mode block, request IDs. We've got a lot of information there, and we can see what's going on. But you also get back in the headers rate limit information. Okay. So in that scenario, what we're dealing with is I've got that in a way that I can interact with programmatically as well. So it's not just a case where I have to call rate limit API point. I'll get this information back in all of my API calls. So again, we start thinking about what I said about engineering your pipelines in a way that you're going to be looking at, have I got plenty of access of time left to be able to do this work? So if we move that on and we'll start authenticating. I'm passing in a bearer token. So it's the same as we did before. We're going to call to the octocat. So I can call the API and then I get a response. In this case, I get a text-based response back with a little picture and a message. if I then come and have a look at my authenticated rate limit, you can see here now I have a limit of 5,000 calls that I can make, which is significantly higher than the unauthenticated. So when the platform knows who I am, they trust me more. They'll give me more access. Okay, so just bear that one in mind as well. Then we start thinking about, okay, well, I want to go and get some repos. So we come across to here. We've got the main part of the URL there, but user and repos. So what this will give me is an indication that there's multiple user elements that I can call back. In this case, I'm looking for all of the repos for the authenticated user. And if I do that, I'll get a lump of JSON back. Here we go. And this is the body of the response. So this is the actual data which is being returned to us. And you can see here who the owner is, what the login is. There's test repo. Get all the information that lives in that. And that's where we can start saying, okay, well, what does the response look like? If I come down to here, and we'll pull in the repos from, just modify this to get rid of that. Okay, so what we'll do here, I'm going to talk to an organization now. In this case, it's going to be Data Plat. So this is Chris Lemaire and the team behind DBA Tools. And what we're going to do is we're going to basically go and say, pull back all of their repos, but I want you to limit it to 5 records per page. So that's our pagination volume. So in this case, I can use a URL level parameter, which says, give me no more than 5 per recall. Okay, headers, the same. So if I go and run that, do a send, you'll see here, we've got our JSON back. Now, if I minimize or collapse some of these, boom, 2, 3, 4, 5. You'll see there, essentially I've collapsed down 5 lumps of JSON. Okay. Now, this is where it starts to get really interesting, is if I come to, okay, there's a question in chat, I'll address that in a moment. So one of the things we can look at here is, okay, well, how do I know how to get to the next page? And this is where we start looking at the headers. This piece here, this tab, essentially is just a sort of mashup of all of them. But what I want to do is find this one, which is referred to as link. Okay, so the link response in the response header gives us these, oops, wrong one, that's the one. Okay, so you'll notice here that it says, right, this is the URL, and repos per page is 5. Page 2 is our next page. Page 8 is our last page. Okay, so if I then come up and I'll just, for the parameters, and say page equals 2, our URL now has the same structure. If I run a get, send that one down. What we'll do is if we look at the link, you'll notice now we've got more. So now that I'm into the guts of the data set effectively, where I've got, right, what's the previous page? Page 1, next page is page 3, last page is page 8, and the first page is page 1. This is essentially the standard format that is supported. This is the RFC standard format that allows for easy sort of retrieval of next page, previous page, that type of thing, navigation through the pagination of the response from the API. So that's a very good quick look at the REST APIs. We'll have a quick look at GraphQL. This is where we've got, if we look at our headers, so far so similar. What we do is now we're actually sending a query essentially in the body of the text. So we're sending a request body. In this case, that's what this supports. And I'm saying, give me my first 5 repositories. Okay. And then these are the values, or sorry, these are the attributes of the data that I want back. So GraphQL is more of a sort of server-side response. So that one has more of a schema on that back end that we can query, rather than just give me everything and I'll figure out what's in the JSON. Okay. So in this scenario, what I'm saying is give me the name, description, created at, disk usage, so on and so forth. Okay. So if I run this, what we end up with is different JSON sort of structure coming back. So there's the viewer repositories, there are the nodes, and then there are the values. So again, I can see all of that information come back. So this is more akin to the way that we've queried databases historically. But you'll notice the JSON response is different. So there's going to be more processing work that needs to go into handling this when we start ingesting it into our solutions. So quickly look at ADF, which is our friend. So let me just bring that across. Okay. So if I bring ADF in, what I've got here is a very basic pipeline. Okay, so quickly run through ADF. Over here, I have some of my linked services. I've got a REST link service, which is supported, so a generic REST one. If we drill into that and have a quick look, what we have here is we're using the auto-resolve integration runtime, but here's our base URL. Now, I've hard-coded everything into this just so that it's easier to see, rather than saying, trust me, all this dynamic stuff works. This way we can see it. Authentication type I'm saying is anonymous. The reason being is I will define this elsewhere when we come to call the API. Okay, so I set up a basic REST API link service. We come up to the pipelines, and if I expand out my data sets, if we look here, I've got my GitHub repos, GitHub JSON. So I'm basically going to be landing into a JSON format. If we look at my GitHub repos one, this is the one where I'm using my REST link service. And this is the relative URL. So it comes back to what we were looking at earlier. I want to go user repos 5 per page. Okay, so we're going to go on the pagination piece. No more parameters there. So what if we come back to the pipeline, click onto the copy data task, come down to here. I'll make this a bit bigger so I can zoom in. Here we go. So what we have is this is the data set we're using. We're going to send a get. Okay, and this is where I then start saying, okay, well, this is my authorization header. So I need to start building that up here. So where I said anonymous on the REST API connector, the generic one for the REST service, here I'm actually saying override that. So it's like having multiple layers of tracing paper. And as I build it up, I get the fuller picture. And here I'm basically saying the bearer token is this plus the token. Now, you don't want to be hard coding security tokens or anything like that into these sorts of environments. What you want to be doing is looking them up by going to Key Vault and what have you. So that's what this web task does. It calls the Key Vault API to pull the data in. And then from
we have
there,
a question.
Yes.
We have a question on the chat from Vincent. Is there a definitive comprehensive API tutorial for beginners that you or anyone else can suggest, recommend? So maybe after the meeting, or
no problem.
Fast.
I can do that. That's fine. So let me think about that one. There's a few things that I can think of. I will cover them just as we get to the end. So that's fine. Nearly there. So so this one here, we're going to call the Key Vault API. Now, obviously there is Key Vault integration, but being able to retrieve a specific secret to be able to inject it as part of this is one of the options. So this is where we've got to start making some compromises. Now, this is one thing where working with the Azure platform or a cloud platform where I'm dealing with native services, if you will, the authentication mechanism here is system managed identity. So I can use system managed identity, I can use service principal, whatever. But this is where I've got the ability to say, actually go into Key Vault and I'm going to allocate a sort of authorization and say this service or this identity can have access to read secret information. Just remember the granularity you're dealing with when you get to Key Vault is not fantastic. So just be mindful about what else you put in there. You probably really want to look at multiple Key Vaults that are very tightly scoped to the activities you're doing. That's the resource. One thing I quickly say also here, if I go to the end of the URL, so we've got the secrets. So essentially the first half of the URL is to say, where am I going? Key Vault. So the name of the Key Vault. This is the secrets API that we're going to talk to. This is the name of the secret, which again, you're going to make into a parameterized option. And then API version. Here it's just 7.4. So it's a numeric value. And again, it's something that you need to go to read the documentation to be able to pull that up. Okay. So what that does, it retrieves the token, pass it down, we pass that in. Now, depending on the API, it can be something as simple as this: is I've got the token stored, it doesn't expire, off we go. It can be a case of I create a pipeline where I have to do the full OAuth token retrieval, where I'm pulling the client ID, the client password, the refresh token information and the token, pulling all of that out, along with the URLs for the token refresh, doing the token refresh, passing that down the pipelines. So it can be something that can be very, very complex. And I have got some blog posts I'm working on at the moment, which will elaborate on that and provide some examples. But fundamentally, once we do this work, the other thing to look at here when we come to the copy activity is the pagination rules. And in this case, RFC 5988 is the mechanism that the one that GitHub uses where it provides those URLs. So that's really great because it gives you that whole sort of when is it complete logic and things like that. You can come down here, if I go next, and say, okay, well, what am I building in here? I've got headers, end conditions, all that sort of stuff that I can specify. End condition, max request number. Basically, I've got to build up, I can use the pagination rules to build up logic. Say, when am I done? Okay, but it does get more and more complex, and especially when you start adding dynamic content to it. So just bear that one in mind. And then when we run that, off it goes, it does the work for us. If I come across to my storage account, and here's one I did earlier, I didn't bother giving the file a name, but fundamentally, if I click into this, and then on edit, zoom in here, you'll see I have 20 rows of data. I was calling it 5 pagination, basically limiting to 5 rows. So essentially this made multiple calls and put all of the data into one file for me. So pagination, when it works and is implemented well by the API, worked well with something like ADF, I can end up with a coherent file. And in this case, I've got the data in such a format that it will work well with Spark because I've got lots of sort of one-line JSON documents, which means it can do parallel access. If I was doing GraphQL and I had one big lump of JSON here, then I've got to think, do I want to take the hit on single thread access and do that processing with my very expensive Spark side of things, or do I want to build another pipeline that will do some pre-processing, or do I want to do post-processing after I land it, or do it in progress as I'm landing it to get it in the format I need for my data to work with. So those are the options, but essentially that's what we can do. We start pulling that data down. You can obviously manipulate it and land it in another format. So if you want to land it into Parquet, obviously you can engineer that in your pipeline, but it's outside the realm of the API calls and the data we're retrieving from the API. Hopefully, if you want to land it in Parquet, the data you're going to get back is in a format that means you don't have to do when dealing with heavily nested JSON and then trying to convert that into something that is more structured like Parquet or a database table or things like that can be very, very painful. So with that, we'll jump back to the slides. What does the future hold for us? Well, I can see more and more API usage. GraphQL is really coming up. That came in 2015. Facebook developed in 2012, released publicly in 2015, and people are using it and bringing more and more of it out. APIs for analytics services like Microsoft Fabric, things like Databricks as well. There's a lot of API elements where you can interact with it to basically do configuration options, deployment elements. So I think as data engineers, outside the realm of the standard data pipeline that we're building, when we start thinking about some of the CI/CD pipelines that we are going to be building, that is a scenario where we're going to be interacting with APIs in a slightly different way. We're going to be do deployments potentially through APIs using CI/CD pipelines. So again, something to think about there versus the older tech like Synapse, which is very much service driven. It's a big shout out to anyone who's developing APIs, taking into account the requirement to do analytics type activities, so bulk activities. There are some APIs out there that have got bulk APIs, if you will, but there are limitations around how that works. There are others that you can send a job to and then you have to poll them. So there's a more sort of traditional process of send the work, poll it. Have I got the data? Have you got the data? Have you got the data? Give it back to me. What would I like to see? I don't know. I mean, obviously shuffling a lot of data around in binary format. So if I'm sending back Parquet, for example, something that's going to be painful. One option could be a case of, okay, well, I'll leverage cloud architecture and say, here's a mechanism, here's a storage account or an S3 bucket. I want you to send this data to that bucket. And then I have an event-driven framework that says when the data lands, I pull it straight in. But again, it's about understanding how does that fit in your architecture? What are the risk profiles for being able to do that? There's a lot to be sort of thought about how to interact in a more sort of analytics or bulk nature for data engineering with APIs. One thing to just quickly custom that as well, anyone who's building or looked at sort of data mesh and data products, think about adopting the API versioning sort of mindset when it comes to publishing your products, okay? Look at ways that you can basically publish a version of your product that's at A, B, and C, so that people who are consuming it are not closely bound to changes you make. So you say, right, we've got current and 2 previous. vNext lands, sort of 2 previous, that one is being discontinued in 3 months' time. But you come up with that sort of deprecation methodology and mindset, and then that will help people when they are consuming your data products to plan around the upgrading and updating their systems that are consuming that data as well. So take that API mindset into the work that we as data engineers are doing when we're building data products to facilitate better interoperability between us and the consumers of the data. So in summary, you're going to spend a lot of time reading documentation. Every API is different, different nuance, different implementations, token expiry, authorization, rate limits, whole raft of different things. Data coming back to you, that'll be different formats, headers you need to provide. There's lots of things you need to consider there. And then understand where you're going to do those transformations to turn that raw data from whatever you've got it coming back into something that is usable for you. Are you doing part of the landing pipeline, pre-processing, post-processing, however you want to look at it? Okay. So there's any number of different ways you want to sort of figure that out. So that's been the session. Thank you very much for your time. I will look at the chat. So we have got the Vincent's question about definitive comprehensive API tutorials for this. There's nothing that I can think of there at the moment. The way that I learned is I picked a relatively friendly API and went to play with it. GitHub is a good option for that because the documentation is pretty good, it's pretty robust. There's clear information about how to use it effectively. And if you start thinking about some potential use cases for data you want to pull in, I am in the process of looking at building out some content around getting started with APIs. So I'll keep an eye on the blog, but beyond that, I can't think of anything. There's a lot of really good people out there who interact with this stuff. So, I mean, check out the Advancing Analytics pages, their blogs, their people have always got good stuff coming out, and generally look at sort of those community members that are working with it on a regular basis from a data engineering perspective. Sorry, I can't give you a better answer than that. But yeah, watch this space. Hopefully I'll get some content out in the next couple of months that's a little bit more user-friendly for getting started with using APIs with data pipelines. Oh. Contact details should still be there on the screen. Feel free, like I say, connect me on LinkedIn. If you get any queries, questions, you want to follow up afterwards, email address is there as well. Always happy to chat.
Thanks a lot, John. It's a great session. Very important information. We will share the recording. It will take a few days. Usually we do it on Monday. Not because we need this time, but it's best to do it after the weekend. I gave you a few links of mine on social media if you have any question. And again, I remind you, join the Future Data Driven Summit as early as you can register. And great session, John. If there are last questions, I think that you answered everything. So have a great day, everyone.
Thank you very much, everyone. Take care.